Hello, this is Mrs. Reed, and today we are going to be reviewing everything that we have done so far the past week for your quiz tomorrow. So this first page here, the definition up at the top is a quadrant. So remember, a quadrant are the 4 regions on a coordinate plane. And on the coordinate plane, remember, if you were to draw a big capital C, that is the direction that the quadrants go, and we label the quadrants by Roman numerals. So this top right is quadrant 1, top left is quadrant 2, bottom left is quadrant 3, and bottom right is quadrant 4. So again, if you draw a capital C, that is the order that your quadrants go in. Okay. Bottom part, you are to list the given coordinates. You are to list the coordinates of the points shown. So remember, you always start at the origin, and you always travel on the x-axis first before you go up and down. So if I'm going over here to A, I'm going to go back 1, 2, 3. So that means that that's a -3, and up 1, 2, 3, 4. So my ordered pair is -3, 4. And please remember, we always put parentheses around our ordered pairs. Okay, so let's try B. So B is over here, so start at the origin. We're going to go to the right, 1, 2, 3, which means that it's a +3, and up 1, 2, 3, 4. So that means that it's a +4. So that order pair is 3, 4. C over here is +1, 2, 3, 4, 5. And then now, since we're going down, this is going to be a negative number, so 1, 2, 3. So we went right 5, down 3. So our order pair is 5, -3. D, we went right 1, so that's a +1, and down 2, so that's a -2. So that order pair is 1, -2. And then the last one over here is E, so we went to the left, 1, 2, 3, 4, 5, so that's a -5, and down 1, 2, 3, 4, 5, so that is also a -5. Okay, so main thing to remember here is that your x value is the first number and your y value is the second number. Okay, next part. So plot the point on a coordinate plane and describe the location of the point. So now we're going to be plotting them. So they want us to plot 3, 4. So again, start at the origin. 3 is a +3, which means we're going to go right 3. 4 is a +4, so that means we're going to go up 4. And this is where that location is going to go. And the location of this point is in our first quadrant. So I'm going to label the location as the Roman numeral 1. All right, next one, -2, -6. So negative says that we're going to go left 2, and another negative says that we're going to go down 6. So 1, 2, 3, 4, 5, 6, and this is where that point goes. And then we do need to label that location. So notice how this is quadrant 1, quadrant 2, and this section is quadrant 3. And then our last one here, 0, 5. So 0 says that we're not going left and right any. 5 says that we're going to go up 5. So 1, 2, 3, 4, 5. And this is where that point is going. And notice how it's not in a specific quadrant. So if it's not in a specific quadrant, you just label it by the axis that it's on. So the axis that is a vertical line is your y-axis. Okay. Next part here is we're going to graph the function and then identify the range of the function. So this is where we set up our t-tables. And what we are doing is we are going to be plugging in our x values. So we are going to be plugging in our inputs into x in our equation. And then we are going to get our outputs over here for y, which we indicate as the range. Okay? So let's see what happens here. So they already did the first one for us, so they plugged -2 in for x, and they saw that -2 plus 1 is a -1. So let's do the next one. So again, all that I'm doing is I'm plugging in -1 for x in my equation. Oh, not times, plus. And then I'm just solving this. So -1 plus 1 gives me 0. Okay, then the next one, so again, I'm substituting 0 in for x, and then solving, so 0 plus 1 is 1. Next one, substitute 1 in, so 1 plus 1 is 2. And the last one, substitute 2 in for x, and then 2 plus 1 is 3. So now what they want us to do is they want us to graph that. So remember, the reason why we inputted our x's was to figure out what our outputs were, so that then these are now order pairs, and I can start plotting my order pairs. So here I have -2, comma, -1, so -2, -1. That's where that is on my graph. Next one I have -1, 0, so left one, don't go up and down any. Next one is 0, comma 1, so 0 up 1, 1, comma 2, and 2, comma 3. And again, guys, we are working with linear functions, so if it's a straight line, then you know that you probably did it correctly. If it's not a straight line, that is your indicator that you did something wrong. Okay, then you have to identify the range down here at the bottom. So remember, your range is just your y values that you found. So all that you're doing is you are relisting your outputs that you found from the table. Okay, so let's try the next one. So again, all that we're doing is we are going to input our domain into our function here for x, and it will output our y values, or in other words, our range. So let's do this. So y equals -1/2 times, because remember -1/2 x means you're multiplying, -4 plus 3. So if we were to take -1/2 times -4, that gives us a +2, and then a +2 plus a +3 gives us 5. So again, I know my video paused, so -1/2 times -4 is a +2, and then +2 plus 3 is 5. Next one, so now we're plugging in -2 for x. So -1/2 times -2 is 1, plus 3 would give us a +4. Next one, substituting in 0, -1/2 times 0 is 0, plus 3 is 3. Substituting 2 in, -1/2 times 2 is -1, -1 plus 3 is 2. And the last one here, substituting in a +4, that would give us -2, so -2 plus 3 would give us a +1. So again, once you figure out your function, your outputs, you can now start graphing your order pairs. So the first one is -4, comma 5. Next one is -2, 4, 0, 3, 2, 2, and 4, 1. So again, you guys should know if you did this correctly by if your function was a linear function or not. And then down here at the bottom, you guys just have to list your range. So what were the outputs that you got? And our outputs were 4, 3, 2, and 1. Alright, remember you guys can pause this video at any time. I'm going to go ahead and move on to slope and rate of change. So remember when we were talking about slope, we were talking about how steep a line is. And we have talked about 3 different formulas for slope. One of them is rise over run, and remember you're using the rise over run formula when you're looking at a graph. We have talked about the change in y over the change in x, so that's the formula that you're using when you're looking at a table. And then the last formula that we talked about was the y2 minus y1 over x2 minus x1, and that formula you're using when you're looking at 2 ordered pairs, okay? Alright, and then rate of change. So the definition of rate of change is how one quantity changes in relation to another quantity. So how one quantity changes in relation to another quantity. Okay, so first thing here says to find the slope of the line. So remember the formula that we're using here when we're looking at a graph is rise over run. You need 2 points on the line to find slope, which they give us those 2 points, and you always start with the point furthest to the left. So here is my point furthest to the left. I'm always rising first before I run, so I'm trying to get from here to here. So notice how I rise up 1, so plus 1 since I rose up, and I ran 1, 2. So if I rose 1 and I ran 2, that means that my slope is 1 over 2. Next one, so same thing. So they gave us our 2 points, and I am going to start with the point furthest to the left, so that is this point right here. Again, I'm trying to get from point A to point B, and to do that, I'm using my formula, rise over run, and we are just counting the rise here. So we're going to count up 1, 2, 3. Remember, if you're going up, that means that it's a positive 3, and then we are going to run 1, 2, 3, 4. So that slope would be positive 3 over positive 4. All right, flipping over to the next page now. So now we are going to find the slope of the line that passes through the points -3, -1, and -2, +1. So remember, the formula that we're using here when you're looking at 2 order pairs to find slope is the y2 minus y1 over x2 minus x1. And remember, order pairs are always in the format x comma y, where your first value is your x value and your second value is your y value. And then when you have 2 order pairs, we say that the first order pair is our x1, y1, and our second order pair is our x2, y2. So when we go to find the slope, all that we're doing is we are plugging in these numbers into our formula and then simplifying. So my numerator is y2 minus y1. y2 was 1. y1 was -1. So here I'm going to take 1 minus -1. Over x2 minus x1, so x2 was -2, x1 was -3, so we are going to take -2 minus a -3, and now we're just going to solve it. So 1 minus a -1 is a +2, And -2 minus a -3 is a +1. So our slope here is 2 over 1, or you can also simplify it to 2. All right, and then B, so again, if you don't feel comfortable with your x1, y1s and x2, y2s, put them at the top there because it does help with knowing what number goes in which position in our formula. So let's go ahead and do what we did here with A. So y2 minus y1, y2 was -2 minus y1, which was 3. And then x2 minus x1, so this would be 5 minus -6. And then we're just going to simplify. So -2 minus 3 is -5. 5 minus a -6 is a +11. That cannot be simplified, so that is my slope. Alright, so with slope, we talked about two special cases of lines that you might see. Remember, if there is a vertical line, we call this a undefined slope. And then if we have a horizontal line, this means that we have a zero slope. So those are the two special cases that you guys need to remember. And the reason why this is, if you guys were wondering, is if I pick 2 points on this line, which they did pick 2 points here. And remember, slope we are talking about as the rise over the run. So here, notice how my line, I can rise however I want. That means that my rise value is there. However, my run, notice how this line is going straight up and down, so that means that we're not running any, so that means that my denominator would be 0. And when I have that denominator of 0, remember that you cannot take a number divided by 0 because this will give you an error on your calculator. So that is why we say that it is an undefined slope. And then same situation with this line over here is, again, if we were looking for the rise over the run, notice how if I pick 2 points on this line, I'm just running forever. So I'm running in both directions forever, and I am not rising whatsoever. So that means that my rise would be 0, and then my run could be whatever number I want. And then when you take 0 divided by a number in your calculator, it does equal 0. So that's why we call it a zero slope. Okay? So same thing that we did up above, find the slope of the line passing through the points and then classify the line by its slope. So again, we're going to take our y2 minus y1 over our x2 minus x1. And you can go ahead and label your numbers if you don't feel comfortable with what number is what. And then just start plugging it into the calculator. So y2 minus y1, this would be 3 minus -2. And then x2 minus x1, this will be 1 minus 1. And if we simplify that, that would give us 5 over 0. So remember, plug that in your calculator and see if it equals 0 or if it equals an error. And in this situation, it's going to give you an error, which means that this is a undefined slope. All right, next one. So -3, 7, and 4, 7. So again, you're taking your y2 minus y1 over x2 minus x1. So in this situation, we're going to have 7 minus 7 over 4 minus a -3. 7 minus 7 is going to give us 0, and then 4 minus a -3 is going to give us a +7. And if you were to plug this in your calculator, 0 divided by 7 is going to equal 0, so this means that we have a zero slope. All right, so now we are moving on to rate of change. So this is the change in y over the change in x that we have talked about multiple times. And they're being, so we're going to talk about slope in real life. So in real life situations is when we talk about the rate of change. So in this example, it says the table shows the cost of a gallon of gas for a number of days. Find the rate of change with respect to time. So remember, we're using that formula of change in y over your change in x's. Your time or distance is always represented by your x value, and then your quantity or amount is your y value. So since we are looking for the change in y over the change in x, I like to look at my y variables first just to figure out that value, since I know that that's the value that's going on top. So remember, when you're looking at the change, you're looking at, okay, what happened from here to here? So if I took 2.09 minus 1.99, it's going to tell me that I increased by 10 cents. Then you do it again. So I'm like, okay, how do I get from 209 to 219? Well, once again, that was an increase of 10 cents. So since I had this constant rate of change, that means that my change in y is going to be that 10 cents. Okay. Then you're looking at your change in x's. So when we went from day 1 to day 2, that was just plus a day. And then when we went from day 2 to day 3, again, that was just plus 1 day. So your change in x's were constant, so that means that your change in x was 1 day. So the rate of change here was for every day, the cost of a gallon of gas went up 10 cents. And just to practice, so if I said explain this rate of change in the situation, remember you're going to start it as for every, and then look at your x value. So for every 1 day, what happened? The cost of the gallon of gas went up 10 cents. So this stuff is on your quiz. So just make sure you guys remember how to explain your slope. Okay. So next one, the table shows the change in temperature over time. Find the rate of change in Fahrenheit with respect to time. So this one is tricky with how they set it up in your table, because remember, like I said up here, your time and your distance is always your x value, and then your price is always your y value. And 9 times out of 10, it's always in this format. So your x is first and then your y is second. However, down here in this table, notice how time is on the right side and our temperature is on the left side. But time is always represented by our x value, and then the amount of something is always represented by our y value. So they actually flip-flop these two, and that makes it a little bit difficult for students to remember what number goes on top and what number goes on bottom in our formula here. Okay, so just be careful with that. All right, so our change in y's is talking about the temperature. So notice how from 38 to 43 it went up 5. 43 to 48 also went up 5, and 48 to 53 went up 5. So that means that your change in y's were constant, so our change in y was 5 degrees Fahrenheit. And then your change in x's, notice how they just went up by 2's every time. So your change in x is 2. Now remember, when we are talking about rate of change with respect to real life situations, we want your denominator to be 1 to represent what happened per hour, per day, per minute, whatever we're talking about. So remember, to get your denominator of 1, you're just finding So remember, to get your denominator of 1, we are just finding our unit rate. And to find unit rate, all that you guys have to do is divide. So 5 divided by 2 gives us 2.5. So this means for every hour, the temperature rose 2.5 degrees Fahrenheit. Last page here. Here we are talking about direct variation. So remember with direct variation equations, slope formula is in the format y equals mx for direct variation. Later on next week we are going to talk about the plus b part, but when you have a direct variation, you have a graph that is proportional. So that means that it's going to go through the origin and it is going to have a straight line. So remember, when you are graphing direct variation, you are starting at the origin, and then your slope is represented by the m in our equation, and this -5 tells you your slope that you are going to perform from the point 0, 0. So I'm going to put a point at 0, 0. And then my slope is -5. So remember, -5 is talking about the rise. So negative means that we're going to go down 5. But please remember that you still need to put a 1 underneath your whole number to show you that you still need to run 1. Okay? So again, with direct variation, you're starting at the origin. Your rise is -5, so you're going to go down 5. And then you are going to run 1. So that is your graph there, and then you do need to put a line through these points because we are graphing the line, and then just remember that you need arrows on the ends of your lines, and that is what your graph should look like. Alright, and then same thing with the next one. So we have y equals 3/5 x. So this is direct variation. So we have a proportional graph. So we are going to start it at the origin. And then we are going to perform slope here. So slope is 3/5. So you're going to start at the origin. You are going to go up 3. So 1, 2, 3. And over 5. 1, 2, 3, 4, 5. Okay, and then you are going to draw your line through those points, and that will be the line of your graph. I do know some teachers, and I know I talk about it too, talk about having at least 3 points on your line to help you guys extend your line all the way out. So remember, if you were to go up 3/5, to get another point down here, you can just go down 3/5, and you can create a point right here. Okay. Same thing with this one over here. So since we went down 5/1, to get a point over here, I could go up 5/1, and then I can extend my line through that point. Okay. All right, last question, write and use a direct variation equation. So remember, direct variation is in the format of y equals mx, where m is represented by your slope. So we just need to figure out the slope of this line here. So here are my 2 points. Starting with the point furthest to the left, I am going to go up 1, 2, 3 to get to that second point, and then I'm going to run 1, 2, 3, 4. So my slope of this line is 3/4, which means I'm going to plug that in for m in my equation, and my equation is going to be y equals 3/4 x. And then number 2 says find the value of y when x equals 80. So all that we're going to do here is we are going to plug in 80 for x, and we are going to take 3/4 times 80, and if you plug that in your calculator, you're going to get y equals 60. Okay, so this is just a basic review over everything that we have talked about the past week, and please let your teacher know if you guys have any questions.